So here we're looking at the arithmetic sequence formula, the general term, a sub n. It's also helpful to know that the common difference is equal to the difference of two consecutive terms, whereas the latter minus the previous. So in this case, our common difference is clearly what am I doing to each term to get the next term? You're adding 2. Well, let's just verify that using this formula here, because this formula will be helpful in later problems. The common difference is equal to the difference of two consecutive terms, where it's the latter minus the previous. So in this case, it would be 1 minus negative 1, which is 1 plus 1, which is equal to 2. Let's verify that by doing another pair of consecutive terms, which would be 3 and 1. So 3 minus 1 is equal to 2. So clearly that common difference is 2. We verified it with two consecutive terms. Obviously, you don't really need it for this problem, but I just wanted to exercise this formula here. So let's first figure out the nth term, and then we'll figure out what the 12th term is. So clearly our first term is negative 1, our common difference of 2, so therefore a sub 1 and 2 will be plugged in. So a sub n is equal to negative 1 plus n minus 1 times 2. So I get a sub n is equal to negative 1 plus 2n minus 2. So a sub n is equal to 2n minus 3. So there's our general term. The 12th term would be 2 times 12 minus 3, which is equal to 24 minus 3, which is equal to 21. Here our first term is 2 radical 5. Our common difference will be the difference of two consecutive terms. So let's do 4 radical 5 minus 2 radical 5. When you're subtracting radical terms, the radicals provided the radicals are the same, the radicals just behave like variables. So therefore this radical 5 is just going to stay, and we're just going to do 4 minus 2, which is 2 radical 5. So our common difference is 2 radical 5, and our first term is 2 radical 5 as well. So our nth term is going to be 2 radical 5 plus n minus 1 times 2 radical 5. And let's simplify this. So I get 2 radical 5 plus, I'm going to distribute that 2 radical 5. So it's 2 radical 5 n minus 2 radical 5. These two radical 5s cancel out. So I get a sub n is equal to 2 radical 5 times n, where the n is not inside the radical. So therefore, if I want to know the 12th term, it's 2 radical 5 times 12. So since there's no radical here, the radical 5 just goes along for the ride, and you can multiply the two numbers on the outside and you get 24. So here we want to find the nth term of the following arithmetic sequence. How do I know it's arithmetic? Well, the common difference of each term is 6. Let's verify that. So d is equal to the difference of two consecutive terms, so that would be 24 minus 30. 24 minus 30, which is equal to negative 6. So your common difference can be positive or negative, hence the term common difference. So the nth term would be a sub n is equal to our first term, which is 30, plus n minus 1 times negative 6. I get a sub n is equal to 30 minus 6n plus 6. So our nth term is negative 6n plus 36. Here we want to figure out the first term, the common difference, and the formula for the nth term. We're given that the 4th term is 3 and the 20th term is 35. So the easiest way to handle this is you can consider this as a pair of ordered pairs. A pair of ordered pairs, yeah. Where the 4th term corresponds to 3 and the 20th term corresponds to 35. And where these 2 points are just points that are on a line. Much like in this example above, if you notice, this is really just a linear representation of an arithmetic sequence, where our slope is negative 6 and our y-intercept is 36. So therefore, arithmetic sequences are really just linear functions where you just plug in different values and that'll give you the different numbers of the sequence. So here we have an x value and a y value, an x value and a y value. I can just use the idea of slope and y-intercept. That'll give me the nth term, and then I can figure out the first term and the common difference from there. So our slope, which is going to be our common difference, is 35, that's 35 minus 3, over 20 minus 4. So that's 32 over 16, which is 2. So that is our common difference. So using that information, can we now figure out the first term and the formula for the nth term? Well, now let's use y equals mx plus b, because we just said that this is really just a linear representation where this is slope and this is the y-intercept. So we have an x and a y value, and we have a slope, which is 2. So 3 is equal to 2 times 4 plus b, which is our unknown. So we get 3 equals 8 plus b. So b equals -5. So our equation of our line is 2x minus 5, where using sequence notation, we would write it as a sub n is equal to 2 times n minus 5. And let's verify that this worked. Let's plug in 4 and 3. So let's just plug in 4 and hopefully we'll get 3. So a sub 4 is 2 times 4 minus 5, which is 8 minus 5, which is 3. So therefore it worked. So lastly, we need to know what the first term is. Well, the first term is you just plug in 1 into 2n minus 5. So 2 times 1 minus 5 is equal to -3. Here are given 3 terms of an arithmetic sequence, but it's written in terms of x. So we want to find the x value such that this is an arithmetic sequence. Well, our general term of the arithmetic sequence formula is helpful, but not that helpful, meaning a sub n is equal to a sub 1 n minus 1 times d is not that helpful, but I find that this formula is very helpful, the formula for the common difference. Let's find the common difference of these two terms. Well, the common difference of these two terms is 3x plus 2 minus 2x, which is equal to x plus 2. And the common difference of these two terms is 5x plus 2 minus 3x plus 2. So I distribute the negative. I get 5x plus 2 minus 3x minus 2, which is equal to 2x. And I use the same d for both of these because the common difference has to be constant, or it has to be common, hence common difference. So therefore, this common difference that I found between these two terms must equal this common difference that I found between those two terms. So that means x plus 2 must equal 2x. So if that's the case, we subtract x, we get x equals 2. Let's verify that by plugging 2 in and showing that this is indeed an arithmetic sequence. If I plug in 2 here, I get 4. Plug in 2 in here, I get 3 times 2, which is 6, plus 2, which is 8. I plug in 2, I get 10 plus 2, which is 12. Clearly arithmetic by a common difference of 4. So it worked. The number 68 is a term in an arithmetic sequence where the first term is 35 and the common difference is 3. What term is it? Well, we have all the makings of the general term of an arithmetic sequence, where we know that I don't know what the term number is, but I know 68 is a term. I know the first term is 35, and I know the common difference is 3, so I'm looking for the term number because it says what term is it. So n is unknown. Our common difference is 3. So we just solve for n and we'll figure out what term number it is. So subtracting 35 from both sides gives me 33 equals n minus 1 times 3. We'll distribute this 3, so we get 33 equals 3n minus 3. Add 3 to both sides, you get 36 equals 3n. Divide by 3, you get n equals 12. How many multiples of 8 are there greater than greater than 25 but less than 600? Well, what's a multiple of 8? Well, 8 and then 16 and then 24 and then 32 and such and such. So therefore, the largest multiple of 8 greater than 25 would be 32. The next multiple would be 40. 4 times 6 would be 48. 8 times 7 would be 56. All the way up to, well, we need to figure out what is a multiple of 8 that's less than 600. So if I do 600 divided by 8 on my calculator, I get 75. So 600 is actually a multiple of 8, but we want to get one that is less than 600. Well, what's going to be the next multiple less than 600? That is a multiple of 8. Well, we'll just subtract 8, because notice the difference between each one of these terms is 8. So 8 less would be 592. The question is, how many multiples are there that are between 25 and 600 that have to be a multiple of 8? Well, we have a common difference of 8, and our last term is 58, and our first term is 52. Excuse me, last term is 592. Our first term is 32. So using our general term of an arithmetic sequence, we get 592 equals 32 plus, I don't know how many terms, that's what I'm looking for, times the common difference of 8. So I subtract 32 from both sides. 592 minus 32 gives me 560. And let's distribute this 8 here. So I get 8n minus 8. Add 8 to both sides. I get 568 equals 8n. Divide both sides by 8. 8 into 56 is 7. 8 into 8 is 1. So the number of terms that are greater than 25 but less than 600, multiples of 8, there are 71 of them. Here we have another radical situation. We want to find the 12th term of the following arithmetic sequence, where our first term is 2 radical 5, and we need to determine our common difference. So our common difference is going to be the difference of 2 consecutive terms, so negative radical 5 minus 2 radical 5. I subtract those two, I get negative 3 radical 5. So to determine the 12th term, we'll use the general term of the arithmetic sequence again, which would be 2 radical 5 plus, in this case, 12, because that's our n value, 12 minus 1 times the common difference, which is negative 3 radical 5. So I get 2 radical 5 plus 11 times negative 3 radical 5. 2 radical 5 minus 33 radical 5, which gives me negative 31 radical 5. Number 9, how many positive integers less than 750 end in 9? Well, what's the first number that ends in 9 is 9. The next one is 19, and then 29, and then 39, and then the last one, less than 750, would be 749. So the question is, how many are there between from 749 all the way down to 9? Well, our first term is 9, the last term is 749, and the common difference, if you notice, I'm going up by 10, so the common difference is 10. So the question is, how many terms do we have? So it would be 749 equals 9 plus I don't know how many terms, and our common difference is 10. So I subtract 9 from both sides. I get 740 equals 10n minus 10, distributing the 10. I add 10 to both sides. I get 750 equals 10n, divide by 10. I get 75 equals n. So 2 problems left here. Find the 6th term of the following sequence. So the first term is pretty straightforward. It's the comma is here, so there's actually 3 terms. And the first term is negative 2 plus radical 3. The second term is negative 1. The third term is negative radical 3. So again, what is our common difference? Our common difference in this situation is negative 1 minus the quantity negative 2 plus radical 3. So our common difference is negative 1 plus 2 minus radical 3 by distributing this negative gives me 1 minus radical 3. So our common difference is 1 minus radical 3. So our 6th term will be a sub 6 is equal to our first term, which is negative 2 plus radical 3 plus n minus 1. Well, n in this case is 6, so it's 6 minus 1 times our common difference of 1 radical 3. I get negative 2 plus radical 3 plus 5 times 1 minus radical 3. Note I can't combine these 2 terms because they're not like. They both have to have a radical 3 in them. So moving over here, a sub 6 is negative 2 plus radical 3 I'm going to distribute the 5. So plus 5 minus 5 radical 3. So I get a sub 6 is equal to 3 minus 4 radical 3. The last term is, what is the 7th term of the following sequence? What is the 7th term? Well, our first term is 1 plus I. Our 7th term will be, well, first we need to know what the common difference is, much like we did in the previous problem. So that would be 2 minus I minus 1 plus I. I'll distribute this negative here, so I get 2 minus I minus 1 minus I. So 2 minus 1 is, I only add up the like terms, which would be the constants and the i's. So I get 1 minus 2i. So the question is, what is the 7th term? Well, the 7th term is equal to the first term, 1 plus I plus 7 minus 1 times the common difference of 1 minus 2i. I get 1 plus I plus 6 times 1 minus 2i. I get 1 plus I, distributing the 6. I get 6 minus 12i. Adding like terms, adding the I terms and the constant terms, gives me 7 minus 11i.